Okay, well, let's keep going here with Newton's first law. I hope you enjoyed that um, little experiment where I'm smashing Jolly Ranchers. Those saved our life. We finally figured out that something we could use to demonstrate with the sledgehammer, with the rubber mallet and the lead brick. All right, so the net force is a vector sum of all the forces acting on an object. So you take the vector means they've got a direction. All the forces, like when we're looking at the coffee mug sitting there, it's all the forces with a certain direction, okay? So inertia is the initial tendency of an object to remain at rest or in motion in a constant straight line. Like if I roll a ball bearing across a marble floor, that's going to keep going along at a constant speed for a long time. It will eventually, due to deformation, heat, noise, all kinds of stuff, chatter, it will eventually come to a stop. But all of this was very counterintuitive because Aristotle said everything has a tendency to want to stay at rest. No, that was based on what Aristotle saw. Everything seems to want to stay at rest because there's all this friction, all these other forces going on. Newton said no, everything wants to stay in a straight line, but there are all these forces acting on it, making it come to rest. All right, so the mass is a quantitative measure of inertia. The mass we measure in kilograms. You've already used that before. Mathematically, now don't be afraid, the net force is written as the sum. This is a sigma, means the sum in mathematics. So the force is F. It's the sum of all the forces. And Newton's second law is the sum of all the forces, F equals ma. F equals mass times acceleration. And acceleration is huge. Okay? Understanding one of the biggest things I think I could teach you is the difference between acceleration and speed. We have this our whole lives. You kind of associate, if you're not in doing physics, you've kind of associated acceleration and speed as kind of the same thing but different. They're completely different, and velocity is completely different than speed in my physics class, my upper physics class, because velocity has a direction. All right, let me show you. Let me give you a quick example. Just this will be an eye roller, okay? Because now we're into the second law, and we'll go on to the next. What I want you to do is follow along, is watch my little thing here that I do on the for showing you what an acceleration is, and then go ahead and watch all those videos on inertia, like the tablecloth trick and all that kind of stuff. It's really kind of fun. And what the tablecloth trick is trying to show you is that those objects don't want to move unless they're experienced by an outside force. And hopefully we pull that tablecloth has enough, if you made that tablecloth out of sandpaper, everything would fall. Okay. Did you see how he made that thing in the Mythbusters one? You'll see how they make the thing so there's almost no friction. And so those objects will just want to stay at rest. All right. Well, anyway, let's go ahead and watch this real quick. And here's what we mean by an acceleration. All right. And we'll do more of this. In your pre-lab, you've got 28 questions. It's kind of, I kind of went crazy. And I apologize. But it's good for you. And I do a pre-lab little movie for you too. Well, several, because it takes me about 15 to 20 minutes. Like I said, lots of instruction, but I want you to just enjoy this. Watch all those little movies. There's little questions hidden in the homework over it, but in the pre-lab over them. But you'll see. All right. But anyway, so here's what we mean. Here's the speed. So let's do pre-lab 4 notes. Speed, 70 miles per hour. Velocity, 70 miles per hour east. Magnitude and a direction. This just has magnitude. Okay. Acceleration. Acceleration is the change in velocity over the change in time. That delta means the difference. Subtract. If I have if I have a final velocity of 10 meters per second, and I have an initial velocity of 2 meters per second, and that happened over 4 seconds, then the acceleration of this object is 10 minus 2 divided by 4, which is equal to 8 divided by 4, which is 2 meters per second squared. In other words, if this object is not, if it's allowed to keep doing this, keep accelerating like this, something's pushing on it, and with a force, it's accelerating it like this, it will get going really fast in a big hurry, because every second it's gaining 2 meters per second of time. And that's like 6 miles an hour. 2 meters per second is about 6 miles an hour. So after 30 seconds, if nothing changed, it'd be going 180 miles an hour. No, it's more like 5 meters. Sorry. All right. I do that every once in a while. I'll start to think. But anyway, that's what an acceleration is. And then force, say I have an object that weighs 5 kilograms, then the force on this object caused by this acceleration is 5 times 2, which would be 10 newtons.